Welcome everyone to this AS2 webinar presentation. On the screen, I have a slight promotion today. So we have on August 12th through 15th, the Association for Software Testing has its annual conference, which is CAST. So CAST 2019 is going to be in Cocoa Beach, Florida. This is a QR code if you put your phone up to it. If you're interested in any information, either about the tickets or who we have going and presenting and talking, go ahead and just take a snapshot of this and this will take you right to the website. So today our guest is Lisa Crispin, who's going to be presenting on visualize how changes flow to production. Lisa is actually going to be giving a tutorial at CAST with Ashley Hunsberger on the whole team approach to continuous delivery. So she's actually doing a tutorial on August 12th. And then we've got other tutorials on the 13th, and then the conference runs the 14th and 15th. And so Lisa is, I'm really excited to have Lisa today. She is the co-author with Janet Gregory of More Agile Testing, Learning Journeys for the Whole Team, which is the most recent book. There was a book before that, Agile Testing, a practical guide for testers and Agile teams. Lisa was voted by her peers as the most influential Agile testing professional person at Agile Testing Days in 2012. She's also a testing advocate working at Mabel to explore leading practices in testing in the software testing community. So that's a little bit about Lisa. Lisa, let's go ahead and hand you the presenting.
Alrighty. It's great. Thank you, Chris. It's so great to be here. Let's see.
Okay, now you should.
Okay, so show my screen. There we go.
There we go.
All right. So hopefully everybody can see that just fine. And thank you. It's a great honor to be able to be on an Association for Software Testing webinar. It's very cool. And I'm really excited about CAST 2019. My first CAST was last year, and it was in the same venue in Cocoa Beach. And it's just one of my absolute favorite conferences, a great size for conferences, and people who are there are really engaged and ready to learn, and I do have a lot of fun together. So I encourage anybody who can to join us there. Today I'm going to talk about something related to the tutorial that Ashley and I will be doing there. And this is the idea of visualizing what happens when someone on your team checks in a change to your product. How does that get? What happens? What has to happen for that to get out to production? So we'll explore that. And just a lot of people have helped me in the past couple of years learn about this stuff and come up with ways to help other people learn about it. Abby Banker, Ashley Hunsberger, Lisa Hawk, and other people. So many thanks to them, and check out their material too. Oops, and then my PowerPoint doesn't want to advance. There we go. So thanks, Chris. I've already told you about something about me. I've been a hands-on tester on Agile teams for a couple of decades now, and Janet and I have written these books together. And we also have a 5-hour live video course available, and we also have a 3-day live training course available with trainers that work with us all around the world. So that's really exciting for us. And not too many people know about this yet. We have a new book out. It's just out in beta right now on LeanPub, Agile Testing Condensed, a brief introduction. So that's our other books are gigantic. They're 550 pages a piece. If you don't want to read a giant book, you can read this really brief book. So we're hoping that'll help people as well. And I'm a testing advocate at Mabel. I really enjoy getting to work with the software community and help everybody learn ways to solve the testing problems that we have. And in my spare time, I hang out with my donkeys, Marcella, Ernest, and Chester. They're very agile. So today I want to help people who may be new to DevOps, continuous delivery, all this continuous stuff that we hear about these days, help you first speak the language of it so you can talk to your team members who are engaged in this, understand some terminology, and then talk about ways we can visualize the flow of each new change in our coding or configuration or content, whatever it is, from committing it to our source code control to deploying it to production. So we can understand that better and keep improving it. And then one way to improve it is the test suite canvas from Ashley Hunsberger. So I'm going to go into how to use that to improve your automated test suites, and talk about how to shorten the feedback loops that these tests give us. We have these pipelines and tests so that we know right away whether we can be confident in what we would like to deploy to production. And Janet and I have been saying for a couple decades now, and we have enjoyed seeing so many teams understand this and be able to achieve it, that quality and testing are a responsibility for the whole team. First of all, you have to commit to the level of quality that you want to produce, and change your mindset to preventing bugs, to learning from production use. We're going to make errors. How can we learn to respond fast to those errors? And again, that gets back to our pipeline. How do we get those things out to production fast? And while keeping an eye on what's really valuable to the customers. So only delivering what they really want. And because we use the whole team approach for this, we have people in different jobs, different roles, different skill sets, hopefully different unconscious biases, so that we can see the whole picture together and keep finding ways to improve. So when we talk about DevOps, it has the word dev and ops, but testing is really the central part of it. And of course, we don't want to forget the business stakeholders, because they're why we're here in the first place. So it's about working together, continuously learning about what our customers need, what we're doing, and how we can improve it. And we really need good collaboration and communication skills for that to happen. So that's one of the reasons I like using these visual models, is they help us do that. If you haven't read the 2018 State of DevOps Survey Report, I highly recommend it. And one of the things that they found, just at a high level, is high-performing teams really have much lower numbers than low-performing teams for things like deployment frequency, lead time for changes, how long does it take from starting work on a new feature to actually delivering it to customers, time to restore service. So if we have a production outage, how fast can we restore that? Or if just a capability in production, we lose that, or customers lose that, how can we get it back? And then the change failure rate. So you can see it's a dramatic difference between the high and low performing teams there. And obviously, most people would like to be more on the fast side of those things. So I know it's a webinar. If you were in a room with me, this would be a little easier, but I'd like you to try just hopefully you all have a piece of paper and something to write with, and just imagine the scenario that your team's product just discovered there's a showstopper bug in production. You've got to fix it, and you can't revert. You've got to get a hot fix out there. And a pair of developers on your team they wrote a test to reproduce the problem. They've got a fix to the code, and they're going to check those things in. What has to happen for the fix to get out to production? What are all the steps it has to go through? Now, some of you may have a lot of these things automated, and some of you may be doing a lot of it manually. It doesn't really matter. These are all steps you've got to do to get to production. So just think for a minute, how would this look for your team? So I'm just going to look at my watch and just give you a few seconds, because it's kind of awkward on a webinar. We don't like just quiet time. If you've got somebody watching this with you, explain it really quickly to them. What all has to happen? I'm just going to give you like 10 more seconds to think. I know that's not really enough time, but just to get into that mindset. So some of the things might be, we have static code analysis, we have unit tests, they may be automated, they may not be automated, we have other tests. What else is going to happen? So now you've thought a little bit about that. What does that look like for your change? Do you even know what the steps are? Because a lot of times we don't have visibility into that, especially testers may not. Another question I have for you is, when you need to get a quick fix for a production outage on the production, do you skip over some automated tests or manual tests to get that to happen to shorten the time? A lot of teams do. And how much of this process that you're thinking about is manual? How much is automated? There's no right or wrong for manual versus automated. It's just probably a question of time. And is that amount of time acceptable to your team and to your customers? So I think many teams are going to say, no, we need to get our changes to production faster, especially when we're talking about a fix for a bad problem. So I'd like to help you learn some of the common terminology so that we can communicate and you can communicate with your teams and talk about how to visualize your deployment pipeline with your team so that you can improve it. So just a few terms for those who may or may not know this, and if you already do, then appreciate your patience. Continuous integration, CI, that's integrating code into a shared source code repository one or more times a day, hopefully many times a day. And you can be doing this on the trunk or master, all working on that, or you could be doing branch-based development. I'm not going to get into that, but I recommend the website trunkbaseddevelopment.com to learn about it. So this is gonna kick off some kind of deployment pipeline, and each check-in is going to be hopefully verified by automated test suites. And I mentioned the word deployment pipelines, but I haven't defined it yet. So the pipelines are just the process or the stages that your code changes go through to get ready to go be deployed either to a test environment or a staging environment or a production environment, whatever it is. And these different stages are designed to provide fast feedback. The earlier stages, obviously, those are faster feedback, so we know right away if our change has maybe broken something else. And the later stages may take longer, but they give us more confidence. And these are central to continuous delivery and continuous deployment, which I'll define in a minute. So this is all part of our value stream. This is something that our teams are going to depend on. And the whole team needs to get involved with analyzing where are our risks, where do we have enough testing, what do we need. Here's an example of a continuous delivery pipeline, and I think it was Abby Banzer who first kind of opened my eyes to this, that we may have, I was always thinking of the pipeline as the automated things, so our test suites and our automated deploys and etc. But the truth is we probably have manual steps like exploratory testing, and those are part of our pipeline. They may or may not happen in line with the pipeline, but they're going to have to happen in most contexts. So this is an example of continuous delivery, and notice that it has these manual steps. With continuous delivery, even when we end up, the changes have got all the way through the pipeline, all the tests have passed, we're still going to make a human's going to make a decision whether to press the button and deploy that to production. And notice deploy to production, it's not the same as releasing it. I'm not going to get too much into this, but we can use things like feature toggles, feature flags, dark launches, canary launches to deploy but not yet release something. So we're not necessarily going to show it to our customers yet, but it'll be there. Continuous deployment, which unfortunately both continuous delivery and deployment are called CD, a little ambiguous there. Every change is deployed if the build passes. So automatically, that's just going to go right out to production. And notice we've still got our manual steps here, but they're out of the main line. So they're being done asynchronously. And again, this is something that you can combine with feature toggles and similar techniques to not turn those features on in production until you've finished these manual steps. So again, that's a whole big topic. Ashley and I will be talking about that more in our tutorial, but I'm not going to get too much into that today. I think the principles of continuous delivery are really important. This is my Bible of continuous delivery. This book came out in 2009 or 10, but still completely relevant. And this book is all about testing. If you read it, you will go, wow, it's a book about testing. And these principles, I think, apply a lot to agile development. They apply to DevOps. These are just principles that help teams do good work. And again, everyone is responsible for doing the best job we can for our customers and to keep improving it. So Ashley Hunsberger uses this analogy, or it might be a metaphor, I get those mixed up, but she says that continuous delivery or continuous deployment without automation, you can do it without automation. You do not have to have automated tests or automated deploys or automated anything in order to do continuous delivery. And I have actually known of teams that did this completely manually and were successful. But in general, in most contexts, it's like driving at night without your headlights. We can do it, but if we turn on our headlights, it would be so much better. And so Ashley says that automated regression tests are one headlight, and testing in production, operability, monitoring, all those other things, learning from production is the other. And I think for testing and quality, we have both these approaches now, not just automated regression tests, but testing before we release and testing after we deploy are both important. So I'm just going to go through these terms again really quickly. So there's a deployment line. There's continuous integration, so we're committing and merging the code. There's continuous delivery. We're getting through all these stages, including a lot of automated regression tests, hopefully, or manual regression tests, other steps. And then the business says, yeah, it's good to go. It got to production. With continuous deployment, that's going to automatically happen. So I hope that's clear. So we have all these pipelines with all these stages, and they can take a long time to run. So we want to get fast feedback, but we also want to be confident. So how can we get kind of the optimal mix of that, of fast enough feedback, but enough information that we feel confident? So we're delivering something and we're learning about it once we deploy it. So, early on, I said to you, imagine you're trying to get a hot fix out to production. What steps does it have to go through? What has to happen to get that out there? This is a great thing to do with your team. And this is an exercise that Ashley and I do in our tutorial. So get a cross-functional group of team members together, or if your team's small enough, get the whole team together. And then stand around a table or in front of a wall, and write the stages or steps of your pipeline on big sticky notes or cards. And this is, if you're a distributed team, you can do this on a real-time board or some online tool. And then arrange your steps or stages on a wall or table, and then talk about it. So this picture is from a workshop that Llewellyn Falco did with his team. It doesn't take long. He did this with a couple different teams just in an hour, and it really doesn't need to take longer than that. So, and you notice here they've shown that some steps are done in parallel, which is a good practice to speed up your feedback loops, and some are not. And the cards are on sticky notes, or the steps are on sticky notes or cards, so that you can move them around and visualize how might you change it, how might you make it better. So this is just a great way to get else talking about it. And this is what I really encourage teams to do. It's a simple exercise, and it's really revealing. So think about, when you're looking at this, how could you deliver faster? We talked about making things run in parallel. Are there different tools you could use? Or if you're not running things in the cloud now, would that speed things up? Or do you need more automated tests? Do you need automated deploys? What do you need? And how can you feel confident? Teams moving to continuous delivery, it's super scary. I mean, if you've been, if it was a shock to you to start delivering every 2 weeks in Agile, as it was to me, well, once a week sounds pretty alarming, and twice a week, yikes. Every day, really? So how do you feel confident to get all your testing done to feel like you're going to put something of good quality into production? And this is one thing that the test suite canvas helps with. So Ashley Hunsberger was inspired by Katrina Cluckey. Katrina Cluckey has an excellent book called A Practical Guide to Testing in DevOps. I highly recommend it. And Ashley's test canvas is just kind of a worksheet. So get your team together and sit down and start asking these questions about each of the test suites that you have. Automated test suites, or maybe you have a manual set of tests that you're thinking about might need to be automated. Or even if you don't automate it, these questions can still apply. So you can see there are quite a few different questions, and I'm going to go through some of those in a little more detail. But you can download this from Ashley's GitHub repo and try it with your team. So let's go into some more detail. So these are things, if we answer these questions and we know we have good answers for them, we can feel confident about delivering to production. So, almost anything we talk about in the software business, whether we're talking about a new feature or we're talking about a test suite, is why do we have it? What's the purpose? Each stage or step in our pipeline, why do we need that stage or step? And honestly, like with my last team, we actually were doing things that we didn't necessarily need to do in our production deploy pipeline because they had been done to death in the earlier pipelines. Do we really need that step? We don't want more things than we need. We want the minimum. Minimum's good enough. And so we want to know what do we want each step or stage in our pipeline to tell us. So if it's an automated test suite, or if it's static code analysis, or doing manual testing like exploratory or accessibility testing, security testing, integration. Can we merge all our code changes that different people on the team are working on? Are we building our artifacts correctly? Are they installable? So these are all business questions that our pipeline, we would like to get answers from. And as we're thinking about this, for each stage in the pipeline, who can benefit from that information? Who needs to know it? How should they be informed? So a lot of times the build will send automatic emails or Slack messages to people, and especially for failures. And are we mitigating risk with each one of these steps? So there's a lot more we can learn. And if we're not learning anything from it, then question why we are having it. So just to give a few examples. So let's say we have a product with a UI and we have an API for it. And probably we want to make sure the API tests are passing, that those responses are correct before we bother to test the UI, because if the API has a problem, then the UI is going to not work anyway. So why waste time testing that? So that could mean let's run our API test suite first and make our UI test suite dependent on that passing. Static code analysis. So maybe the team has set up accessibility standards that are verified by our static code analysis, and is the new code that we've just checked in following those standards? A lot we can learn from static code analysis. Does the build install without any errors? And if it gets errors when we install it, do we want to proceed with testing it? There's not a right or wrong answer. It all depends on your context, but these are questions to ask yourself as you're looking at each of these steps. What needs to be in place for a step to run successfully? So a lot of times we get, our product integrates with other systems, external products, or we need particular tools, or we need particular data for it to work, test environments for tests to run in. There's a lot of dependencies, and we want to look at, are there things, if we're testing external systems, maybe we could use a test double of some kind, a mock or fake, or stub that out, because we're not really trying to test that external system. We're just trying to make sure our system works correctly with it. So these are a lot of places that teams can really find some ways to speed up that feedback for tests that run. constraints. So maybe we're not totally happy with the stage of our pipeline, but something's in our way. Maybe we have a manual step we want to automate, or maybe we have automation, but it's too slow. We're getting false failures. And there could be an emotional constraint as well. Maybe we're just kind of overcome by the difficulty of solving some of these problems, and we can't even get traction on it. Or, maybe we're being pressured to work on other things, but we really need our deployment pipeline to work correctly. It's the infrastructure that we need to work as a team. So, those can be problems. Let's talk about them. Let's identify them. And how does each stage of your pipeline get started? Does something before it, is it dependent on certain steps before it passing? Or can it be run in parallel to shorten up that feedback loop? And there are decisions to be made where, like, maybe you're doing some fan-in dependency management where there are several steps running in parallel, and then they're all going to kick off one step after that. What if one of those steps fails? Do you want to keep going, or do you want to stop, fail to build, alert somebody? These are all decisions we have to make. And gates would be something that stops it. Like, okay, this failed, it didn't pass our gate, it's not going further, and we're going to get this fast feedback of the failure. So learn about the failure as quickly as possible. That may be something you decide to do. So the idea of gating is, automatically stop defects from making it any further in your pipeline. And this is where it's really important to use good practices as you develop your automated tests, and make sure that they're reliable and they're not flaky. Test data is always a headache. So especially, back in the day, we used to just make a copy of the production database and use it for testing. Well, with GDPR and other security concerns these days, we can't do that anymore. So how do we get realistic test data? The problem with testing is that test environments never are just like production. The data is not the same. We can't simulate everything real people would do. And this is where the idea of testing in production can really help us. Again, that's probably another webinar. I shouldn't get into that, but if we're going to simulate production and have a lot of test data, because we probably have a lot of data in production, then that's probably going to slow things down. So do we need to be able to do that to feel confident, or can we do something faster with maybe just a representative small sample of test data? Do our unit tests use, I mentioned test doubles earlier, any test could use these, just faking out interactions with other systems like the database or external systems or the server, because we're just trying to test some isolated component, and we don't have to test all the things it talks to in production. Generally, as the tests that are higher up above the unit level, the teams I've worked on, we use fixture data or canonical data that simulated production data, but was a much smaller set. And so that would be refreshed in the test environment right before we run all the tests, so it's always running on a known state of data. And then each test might set up and tear down its own unique test data. That's a great practice, because then you don't have to worry about one test stepping on another test. So there are a lot of different ways to go about test data, and that's something that your team might have long conversations and long experiments about. Maybe you are refreshing some set of test data every time you run the test, but it's taking too long. It's really slowing your test down. There may be database experts on your team that can help you with that. So this is why we want to get the whole team involved. I remember one time when we were having a problem that took so long to refresh test data, and it was really slowing us down. And somebody had the idea to put up an impediment board. We never had one before. So we put that up on the impediment list, and our database expert saw it, and he's like, oh, well, I didn't know you were having that problem. And he got together with the system administrator and fixed it. He just wasn't aware we had the problem. So sometimes it's just a question of making problems visible. So when our pipeline fails, we want to have actionable alerts. We want people to know about it. The right people need to know about it, and they need to really do something with it. And a lot of times what happens with teams that have a lot of automated tests is, especially if they have UI tests and they tend to be flaky, they start to ignore the failures and like just kick the pipeline off again, just kick the build off again, because that was probably just the test being flaky, and if we run it again, maybe this time it'll work. Well, if your pipeline takes 45 minutes to run and you're trying to deploy today, that's not a great option. And what happens is people just start to ignore it because they're just inundated by so many alerts, and most of the alerts turn out to be not valid. So my last team, we had a problem with this because we were trying to deploy twice a week, and so on Tuesday, Thursday, and if it was Tuesday and our production deploy pipeline kicked off at 2 o'clock, it took 45 minutes to run. And we had big wall monitors, and if it failed, it would, the wall monitor would show all kinds of red, and it was very obvious there was a failure. But everyone on our team paired. We were doing pair programming, pair testing, and that kind of gets your heads down in your work, and you're not necessarily even looking up at your big wall monitor. So a lot of times an hour or so would go by before anyone noticed that the production deploy had failed or the production pipeline had failed. So we got together and brainstormed, how can we discipline ourselves to make sure that somebody takes responsibility to investigate that failure and make sure it gets addressed. And we actually decided to hook a blue flashing police light up in our work area, hook it to our build. And so if the test failed or if anything in the build failed, the police light would start flashing, and it wouldn't stop flashing until somebody said, I will take responsibility to make sure it gets investigated and addressed. They didn't necessarily have to be the one to fix it, but they had to make sure somebody did. And that's a pretty drastic measure to have to take, but it was what it took for us to start taking those failures seriously. And then the other thing to do, of course, is also to address the things that are causing the alerts. If you have flaky UI tests, you can't just throw up your hands and say, well, that's just how it is. You actually have to address that problem. It is a solvable problem. So this is really important. This is something, so I said, get your whole team together and talk about your pipeline. And, I give advice to people a lot of times that I don't succeed with myself. So on my last team, I actually was not successful at getting people together to do that. They're like, pipeline is fine. So I did it for myself, and I just drew it out, and I wanted to specify what are we learning from each one of these steps or stages, and then I also added smells. It's like in this particular step, we've got problems because we've got these flaky tests or these tests that are commented out for now. Oh, that's such a terrible practice. Or failures that weren't stopping the pipelines, or lots of regressions in a certain area. So those were helpful to me, and I also added questions. And so what this did for me was it made me think of questions that I wanted answers from. And so I would just go to talk to team members and ask the questions, and they're like, oh, well, that's a good question, and let's look into that. And so over time, we did solve a lot of problems, answer a lot of questions, and fix some of those smells. And so it helped me understand the pipeline, and it helped me in turn help the team to say, why are we running this stage in the production deploy pipeline? It doesn't seem necessary because we already ran it when we tested the master from which we cut the release candidate. So I would encourage you, if you can't get your team together to do it yourself, and then take the questions that it generates for you, and then go talk to your team about those. And again, there's no right or wrong here. It's just, experiment with it, try it out. The first step to solving a problem for me is always making it visible. once we make it visible, we can make people understand the pain being felt. That's a big step towards getting it addressed. So there's a lot more to that test suite canvas, as you saw. So just use it to get your team talking about these things. And it's really important to make your tests reliable and trustworthy. It doesn't happen overnight. So one thing I've learned from people like Linda Rising is just identify your biggest problem. Use your retrospectives, get your team together, and then set goals around that problem and experiment to make that problem a little smaller. And use some kind of measurement to know if you're making progress or not, so that you know if that experiment is succeeding or not, or if you need to try a new one. So be patient. These are things you have to do in baby steps. You can't boil the ocean. You can't fix everything all at once. So start working on the biggest problem, and then once you've worked on it a while, something else will probably be your biggest problem. You never run out of problems, that's for sure. But you can feel good about the ones that you solved, and keep improving your tests, improving your pipeline, getting faster and faster feedback, and building that confidence. So if you are hoping to work towards continuous delivery, that you don't feel scared to try to do it. So, work together if you can to visualize your pipelines. And again, if you can't get multiple team members to do it, just do it yourself. And then improving the automated test suites and the other automated parts of your pipeline, that's going to have to be a whole team effort. You're going to need help with that probably. So we're going to have to collaborate. And these visuals drawn on a whiteboard, using sticky notes, whatever it is, those are great tools to promote collaboration and get people talking together, get people drawing together, get people writing together. And this is a great way to get the whole team commitment that you need. It's like we do all care about quality. Everybody wants to deliver a good product for the customers. We all want the customers to be happy. So let's just bring that to the surface so that we can talk about ways to do it. And like I say, set some goals, experiment, track your progress, and keep trying new goals. So I have intentionally left a lot of time for questions, so I hope there are questions. This is my donkey Marcella, and she's got a lot of curiosity. She'd be a good tester. So I hope some of you are curious about this and would like to know more.
Yeah, so thanks, Lisa. We do have some questions, but for anyone else that still has them, there's plenty of time. So one of the comments that came from Vernon Richards was, he said that his first reaction when he heard about CD2 was, oh, this is all about testing. So that's really awesome.
Oh, good. Yeah.
And so one of the questions is, do you have suggestions for making problems visible? Because that's a really big thing, but it can be a scary thing. Do you have tips on how you actually go about making those, making problems visible? Like, how does somebody, when they stumble across something, bring it up to the whole team?
Yeah, this could be tough. I mean, it's something, if there's a problem, I want to mention it in stand up, I want to mention it in retrospectives. And a lot of times in the past, I've just, had to work with the Scrum Master on the Scrum team and get that person to help me. So just to give an example, a team I started on in the early aughts, we were just struggling to get our build to even ever pass. Days would go by and we would not have a build. We would not have something we could deploy and test. And this is really a problem. And so one of the things we did was just, as a team, we said, okay, when the build fails, that is the team's highest priority, except for a production outage, that's our highest priority. And so the Scrum Master, when she saw the build fail, she would put just a big red sign up on our project board. So we had a board in our work area with all our stories and tasks on it. And she would just put this big red sign on the board, and that was our signal of, we all have to stop what we're doing. And somebody had to say, okay, I will look into this. And then the rest of us could go on with our work. And that was easy to do on a small co-located team. You would have to get more creative if you have teams that can't all see the task board. Maybe you do it with an online board. Maybe you do it, pop up an alert in people's browser or IDE. There are a lot of different ways to do that. I've seen another team do it where it would pop up a picture of some character in their IDE. So like if you see a picture of Mr. T with all his gold jewelry on, and he's pointing his finger at you. It's like, oh, are you gonna fix the broken build? And you couldn't actually go on with your work unless you answered yes. So yeah, you can have fun with it, but somebody has to take notice and make it happen. Another way we kind of got the importance of having a green build every day was our Scrum Master kept a calendar, and she just color coded it. It was online, and it was like green if the build passed that day, red if it didn't pass, or yellow if just something happened. There was a fire in the server room, so we couldn't even have a build. And it was interesting because she would send this calendar out to the whole business every day, to all the managers, and they started to understand the importance of it. And if they saw red for a couple of days in a row, they'd come over and talk to us and say, hey, why is the build failing? What's going on? And so making the business aware of the importance of this is really important too, making them understand, the opportunity cost to them if we can't get a release out when we want to. So those are just a couple of pretty basic examples. I hope that's helpful.
Great, yeah, that's very helpful. So you showed the test automation canvas that Katrina Clokey made that I think you said
Ashley Hunsberger.
Ashley Hunsberger had yeah. So can you explain a little bit more how that's how you use that, how someone else might use that as a part of visualizing the pipeline or sort of as a part of this process?
Let's see, maybe I'll back up to that. Here we go. You just go step by step through each set of questions or through each square or rectangle on the canvas. And so you pick a test suite. So maybe you've got your API test suite, for example. And then you start by talking about what business question am I trying to answer with the suite? What risk is it mitigating? And then that's a big discussion itself. You maybe can't do this all in one go. And then think about the dependencies. These are just things we don't necessarily think about, especially we don't think about them up front. We're just like, okay, well, we've got an automated test. Let's create a test suite and make it part of our continuous integration. We kind of do that without thinking because it's a good thing to automate our regression tests. But maybe we have a lot of problems with it because we didn't think about the dependencies and we didn't make sure that we had those in place. And we didn't think of ways that, oh, this part for this external system, we could have mocked that out or stubbed that out. Or, we need to make sure we have access to this other thing. So just those are things that we may take for granted and not really think about. Constraints, is it part of a pipeline? How does it run? Is it gated? Is it dependent on an earlier step? And then test data, I talked about that, how we set it up for each test or each test suite. And the engagement and failure response, that's really important. That's why I was talking about the alert fatigue of, are the right people being notified, and is it an actionable sort of thing? Are people really taking action on it? Or maybe we're not telling the right people. Maybe we're notifying the wrong people, and that's why it's not getting addressed. Maintainability, testability, I think maybe I think of it more as testability because we're starting to talk about that a lot more. And Rob Meany and Ash Winter are working on or have a new book on that. Maintainability to test for sure, but let's take that a step further and say how testable is our code, because that really affects our ability to maintain our automated tests. It's all one piece. I might talk to Ashley about changing that part. And then effectiveness, what's the value? Is the suite valuable? Is it finding information? I've heard people say, if an automated test never ever finds a regression failure, do we really need it? And I think that's food for thought, because it takes time. It's overhead. We have to maintain it. If it's something that nobody is ever going to break accidentally, then we don't need to have a test for it. And again, that's domain dependent. If you're in a safety critical, life critical, money critical domain, you may want to do every test you can. So, but these are things the team really has to discuss and make conscious decisions about, instead of just, we're always in a rush and it's like, okay, well, we know we need to automate a test for this, so let's do it, without thinking about the implications and what all might really be involved in automating that test. There's more to it than we thought. So it's just a framework for conversations to make sure we talk about all the different aspects that we need to remember to talk about. You can make your own, for whatever is important to your team.
Fantastic. So another question that we have is, when I perform any deployment, or others do, if someone sees errors, what do you do when engineers say to ignore the errors? As in, like, the application would still work, but like the errors aren't related to us. Do you believe that and go to work? Do you not? Like, how do you sort of get through that situation?
Yeah, I have been told that so many times, and there have been times I was gullible enough to go along with it, and only to find out years later that that really was a terrible problem. So I guess I would just have to be persistent, and it's kind of bad because you feel like a pest, or you feel like the quality police. But to give an example from my previous team, we would see a lot of 500 errors, both in the automated test results and when we were testing manually. And they would, the engineers would say, well, don't worry about that. That's just normal. And it was, it does an automatic retry. So you don't actually see a problem in the UI, but you can see the errors are happening. And it'll retry 3 times. And as long as it works on the second or third try, the user won't see the error. And it really bothered me, though, because if we had a few people working on the same kind of thing on a product that should support concurrency, we would actually start to see the errors in the UI. And I kept bringing it up and bringing it up and bringing it up, and people would say, well, it doesn't happen in production, so it's okay. Well, how do we know it doesn't happen in production? We didn't have such great monitoring. That was a few years ago. And it finally got to the point where the CEO of the company started seeing the errors in the UI. And it's like, oh, we're seeing these errors now. So all of a sudden it's a giant priority to fix it. And that's what it took. So the problem was always there. And that's what it took to motivate the team to actually investigate the problem and fix it once and for all. And it wasn't even all that hard to fix, I don't think, but it was just some kind of contention or some kind of deadlocks type condition. So, I mean, again, it's something to make it visible and just, find a way to get that out in front of people. I wish I had done a better job. I mean, I kept asking about it, but I didn't really do a good job of making it visible. So, maybe, I'm not sure how I would have made it visible there because everything was online for us there, but I did certainly put a story into our backlog, but there's lots of stories in the backlog for that team, so it wasn't very visible there. So I would have to maybe get some allies on the team, other people who agreed with me that it was a problem, and brainstorm with them ways to make it visible, and then go from there.
Yeah, great. Yeah, it's kind of a hard thing when the team ignores it, and yeah, you really don't want to wait until the last minute like that. But it does help when someone comes down from high and you sort of get embarrassed like that, and then the whole team started paying attention to it.
Right.
It's sad, but it works.
Yeah.
And then so there's a couple of questions too. Somebody asked, how do you do code reviews as a tester? Is that something that you do, Lisa? Like, do you generally do code reviews? I think this is related to the Test Suite Canvas, but just as a tester, have you done those before?
Yeah, I mean, mostly I have worked on teams that pair program, and we didn't really need code reviews, but I think it is really important for testers to be involved in those. And I know a lot of times it's like, well, I'm not a coder, and what could I do to help? But the truth is that the developers ought to be able to explain the code to you. And I find that as testers, we think of questions they didn't ask themselves. So it can still be really valuable to, it might be boring sometimes because you're looking at something you may or may not understand, but it's good to learn to read code even if you're not going to write code. So I would encourage, getting yourself invited and elbow your way in if you have to, because we can ask questions that are really important. And I know it can be hard too, just from a time perspective. So you may want to look for, if you're doing pull requests, for example, so that they're reviewing a change for a specific thing. If it's a change for something you're really interested in, go to that code review and get involved in that. Maybe you can't do every one, but you can do the, testers. We're really good at assessing risks. So look for the riskiest ones and participate in those and see how it goes. And a lot of times I just have worked with a team long enough that I trust those developers and I know that they're going to think of all the questions themselves, and so I don't have to be there. But if you don't have that level of trust, then you need to go find out for yourself.
I think it sort of ties into a bit with your visualizing the pipeline. So, like, if you understand where, like, if your company is using Git or GitHub and they're putting up pull requests, then
Mm-hmm.
that means, like, as you're sort of sketching these things out, you can sort of learn about when do code reviews happen and where are they, and then from
Mm-hmm.
there, it sort of makes it a little bit easier to to get into doing code reviews. But like you said,
Right.
I totally agree that testers ask very different questions about the code, and developers should be able to explain a lot of the assumptions and the things that they do. And so that's sort
Mm-hmm.
of a very good introduction to start doing code reviews, for sure.
Right. Yeah. Good point.
And so that's pretty much all we have for questions, unless there's anything last minute. So I just want to say thank you, Lisa, for doing this webinar. And do you have anything else that you would like to say?
No, I hope that maybe some people who are watching this would be joining us in Cocoa Beach next month, and feel free to reach out to me with questions. Let's see, I think I've got a slide with my contact info.
Yeah, how do you want people to reach you? Definitely on Twitter at Lisa Crispin. You can see those in the
Yeah,
slides.
and I
Um,
do have some resources listed here of places to learn more. Um, and there's my contact information. Uh, Okay, Lisa at enable.com. What did I see capitalized? I didn't test my slides. Twitter is a great way to reach me, though. Yeah, that's all I have. So, and I presume that in addition to having the recording of this webinar, we can put the slides up somewhere for people. So
yeah, that'd be great.
do
And
that.
then we can email those around. So
Got it.
again, just want to say thank you, Lisa, and thank you everyone for joining. It's been a great time. So thank you and have a great rest of your day.
Thanks.